Hello, I'm Stuart Winter, the platform architect for Slackware on the ARM platform. In this video, I'm going to walk you through installing Slackware onto the Raspberry Pi 4. Before we do that, I just want to express my gratitude to Brent Earl for all of his help on the project with the R&D for the Raspberry Pi 4 and the other hardware models as well. I'd also like to thank the supporters from Patreon and through PayPal, because with your help I've been able to purchase the hardware for the Raspberry Pi 4 and all of the peripherals. Additionally, last year a lot of the old infrastructure hardware for the port failed, mostly because it was pretty old, but also because we had power fluctuations and a few power outages here. So with your help I've been able to replace a lot of that hardware and also purchase 2 UPSs, which in fact only just last week kept the project up and running because we had 1 power surge and 2 power outages. And so with all of the equipment on the 2 UPSs, it's been up and steady and continuing to build. So thank you very much for all of that. You'll see on the screen at the moment the URL that you can go to where you'll find details about how you can help support the project. In this video, we're going to be having Ellie from the production crew. How old are you, Ellie?
9.
9. Okay, so we're going to have a 9-year-old Ellie following the installation guide, assembling the Raspberry Pi 4 and installing Slackware on it. Okay, let's go. In the Slackware installation guide, I have what I call the Linux host computer, and this is the computer where you'll download the Slackware tree, the installation media. You'll write that installation media to the USB pen drive, and you'll also write the Slackware installer to the micro SD card. Now in this case, what we're going to be using is the Pinebook Pro, which you may recognise from the Pinebook Pro installation guide video. And this is running the AArch64 port of Slackware. Now Ellie, if you click on the KDE Start menu on the bottom left-hand corner. Move to where it says Internet, somewhere in the, where is it?
Here.
Yeah, and then click on Firefox. You only need to click once. Move the mouse over to the Firefox icon. Yeah, that's it.
Yes, fancy. Ooh.
So if you type in arm.slackware.com into the, you need to click on the URL bar there.
Here.
The URL bar is the top bit here. Type in arm.slackware.com.
Wait. Yeah.
Yeah, it's already there because I've been there, so you can press enter. Makes it easier. The first thing to do is to click on the installation link in the left-hand side menu. This takes you to the Slackware ARM and AArch64 installation documentation landing page. Here you'll find the installation documents for all of the supported released versions of Slackware and for the development branch, which is also called current. At the time of creating this video, there is no stable release of the AArch64 port of Slackware. There will be in the future, but at the moment we're going to be using the development branch. As you can see in the table, Ellie has highlighted the 64-bit version of the development branch. So click on the current link there. You might want to use this mouse, by the way, because it's easier, because we're going to be doing a bit of pasting and copying here. This brings you to the installation documentation landing page for the development branch of the AArch64 port of Slackware. So click on the instructions link for the Raspberry Pi 4. So what you're looking at now is the installation guide for installing Slackware onto the Raspberry Pi 4. The installation guides for the AArch64 port of Slackware are all stored on docs.slackware.com, which is the official documentation repository for Slackware. There are many other really useful articles that you can find on here to help you configure and manage your Slackware installations. So I encourage you to check out the documentation there because I think you'll find it useful. So with the Raspberry Pi 4 documentation, the best thing to do with this is to read it thoroughly all the way through, because that way you know what's coming next. Okay, so what I'll do now is walk you through the things that we need to install Slackware onto the Raspberry Pi 4. We're going to be following the installation guide, which is geared up to install Slackware using an HDMI monitor and USB keyboard. You can install Slackware using a USB to serial adapter, but for this installation video, we'll be using an HDMI monitor and USB keyboard here. I also want to point out that the installation guide is geared up to people who have a brand new Raspberry Pi 4 out of the box. The purpose of the installation guide is to list out a collection of hardware that's known good, that you can purchase and set up completely following a guide and have Slackware installed. Of course, many of you here watching this video have probably already got your own Raspberry Pi 4 already set up. You've already got your own cooling fan and perhaps your own case as well. And that's great. You can keep using all of that. In this video, we'll be using the Ice Tower CPU and cooling fan. Okay, so let me walk you through the hardware that we have here. So the first thing that we have is the Raspberry Pi 4. This model is the 8GB RAM version, but you can also use the 4GB RAM version. The next thing is the HDMI mini to large adapter. This allows us to connect the Raspberry Pi 4 to an HDMI monitor. Again, if you're going to be running Slackware headless, you won't need this, and you can install also over the serial adapter. But again, in this video, we're going to be using an HDMI monitor and keyboard, so we'll be using that here. The next thing that we need is a USB to SD card adapter, which we'll be connecting into our host computer in order to transfer the Slackware installer onto the SD card. Once we're done installing Slackware, we won't need this again. The next thing we need is some storage. In the installation guide, there is pictured a USB to SATA adapter. But just to spice things up a little bit, in this video, we're going to be using an NVMe adapter instead. So what we're going to be installing onto this NVMe storage here and using this USB adapter here. I've already installed the NVMe into this enclosure, so that all that needs to be done now is simply to close up the enclosure like that. Done. Next, we need a power supply. I've had many problems with power supplies over the years of doing the ARM port. So I'm recommending that you buy an official Raspberry Pi 4 power supply, or buy one from a vendor that you trust that meets the technical specs required for the Raspberry Pi 4. The next thing is a USB flash drive, or USB stick as they're often called. We'll be downloading the Slackware installation media onto this, and we will be installing Slackware from here as well. You need a minimum of 8GB for this. This one is 32. If you want to install Slackware over the network, perhaps with NFS or with HTTP, you can do that. That's also supported. But for most users, I think for the Raspberry Pi, this is probably the most frictionless approach to installing Slackware. So again, you won't need this though once we've installed Slackware. The next thing that we need is a micro SD card. You need a class 10 micro SD card, which presently is the fastest that you can get. This micro SD card is going to be dual purpose. Initially, we'll deploy the Slackware installer onto it, and we'll boot the Slackware installer from it. And then it will be converted into the operating system /boot partition. So you need to make sure that you get a good quality SD card for this and as fast as you can. When you're selecting a micro SD card for the Raspberry Pi 4, make sure you look at the hardware requirements in the installation guide, because the Raspberry Pi 4 has a few idiosyncrasies where it doesn't quite work that well with certain SD card manufacturers. So make sure that you look at the installation guide and pick one that's known to work. You need a minimum of 8GB for this SD card. This one is 8GB. There we go. Next, we have an inline power button. This is optional. The reason why you want this, however, is because the Raspberry Pi 4 does not have a reset button, nor does it have a power button on board, unlike most other hardware models. So with the Raspberry Pi 4, one of the things you really don't want to be doing is disconnecting it physically from the board every time you want to power cycle it, because you will end up damaging the connector on here for certain. So with this, it allows you to easily just power it on and off with a hardware power button there. That's optional, but I would strongly suggest that you invest in one of those. The next thing is, this is optional. This is a real-time clock, which is going to be connected onto the GPIO pins of the Raspberry Pi 4. I always strongly suggest that you have a real-time clock on the operating system, because if the clock gets too far out of sync, it can upset the operating system. It can cause problems with web browsing and various other things like that. So I'd strongly suggest that you have one, but you don't have to. You can also use NTP to sync your Raspberry Pi if it's connected to the internet. If you're going to be using an RTC, you need these DuPont cables as well. We've got female to male here, and we have 1, 2, 3, 4 of them. The links for all of this stuff is in the installation guide. And lastly, we need a CPU cooling fan. As I said before, many of you have probably already got your own Raspberry Pi 4 set up. But this here, the Ice Tower cooling CPU fan, is one of the ones that was recommended to me by the Slackware community as being particularly good for handling high workloads on the Raspberry Pi 4. To me, that means compiling things, because the Raspberry Pi 4 is going to be compiling packages and testing and all that kind of stuff. And so this one is particularly good at dispersing heat. So that's what we've got here. But again, if you've got your own setup, you can just go with that. You don't need to change anything here. But we'll be, in this video, setting this up. The package comes with the fan. It has a colourful one to begin with, but you can also replace it with a black one. I quite like the colourful one, actually. And it comes with this acrylic baseboard and all this other stuff here, the nuts and bolts and all that kind of stuff, and a heat transfer pad as well. Okay, and we also need for this installation a USB keyboard. And finally, you might want to have a mouse connected, because at the end of this video, we'll boot into one of the window managers and I'll show you that working as well. But again, if you want to run Slackware headless, you don't need a mouse, nor do you need a keyboard. Okay, let's begin with the assembly. Okay, the first thing that you need to do is to take the acrylic base and insert the screws and screw. Yeah, that's right. And then screw in the brass spacers. What you're probably best to do is to just do one at a time, because otherwise they'll all fall out when you turn it over. So put one in, put your finger on it, and then screw the spacer into it exactly like that. You can just tighten them up with your fingers.
It's hard.
That's it. Yep. And then do the rest of them. Yep, that's it. All done.
Should I ask the question?
Yeah.
Why aren't these two at the back like these two?
So to answer your question, you'll see here that the holes line up, the holes in the board line up with the spacers here. And the peripheral end here, the USB connectors and Ethernet port, sit over this end here. So it's just the way they've designed the board, because otherwise the hole would be inside the USB or Ethernet ports here. So it's just the way
they space.
I needed space on the board to put those there, so that's why the holes are in that position. So what you need to do now is be really careful, and that's right, and gently, that's it. Perfect. Next, we need to take the next 4 brass spacers and screw them into each of the brass spacers that are all around the board. But when you do this, to stabilise the board, use your fingers like this rather than touching any of the components on the board, because you could transfer static electricity onto it and damage the board. So be really careful here. So just hold it like that with one hand to stabilise it. And just gently screw those in, that's right.
And touching the board, does that count?
Oh no, that's okay, yeah. It's more about touching the chips on the board that would cause a problem, really.
What chips? What chips? What chips?
No, they're not chips you can eat. They're silicon chips. You wouldn't want to eat those. It'll give you a stomachache.
Yeah.
The next thing is to take the pink heat transfer pad and lay it over the CPU, as shown. That's it. Yeah, that's exactly. You can slide it into place. So that looks...
Yeah, it's fine.
Yeah, that is fine, I think.
It looks weird.
Yeah, that's perfect. Okay. All right, the next thing that we need to do is to attach the mounting brackets onto the CPU fan and heatsink. So you need to be careful here to screw these the correct way round, otherwise you simply won't be able to screw it onto the Raspberry Pi and you'll have to do it again. Okay, to make this pretty easy, when you look at the installation guide, I've annotated a photo of this and it's quite straightforward. All you need to do is, if you look here,
It says 2.
Exactly, it says 2. So this says 2 on the mounting bracket. Now we want number 1 to begin with. What I need you to do is I need you to screw so that number 1 is facing this way, and you can get your bearings here by splaying the power cables, the red to the left and a black to the right, and have it so that number 1 is visible like that. And then all you need to do, Ellie, is simply screw that in there.
Okay.
Yeah? So take the screwdriver.
Screwdriver.
That one. And keep that screwdriver away from the SD cards because that is a magnetic screwdriver. Oh, okay. So when you do this, the easiest thing to do sometimes is to... Do you want me to show you how to do it?
Okay.
That's it. You're getting it, yeah.
So just screw it in. Wait, is this way right?
Yeah, that's right. Okay, so bracket 1 has been installed, and now we need to do...
Bracket 2.
Indeed. Again, you can refer to the installation guide for the positioning of this. The next thing to do is to install the ice cooling tower onto the Raspberry Pi 4. So you do that by positioning the holes in the brackets of the ice cooling tower onto the upward facing brass spacers. Exactly. So just take it there and position it like that and insert.
Push it.
No, don't push it hard. Just, that's it. Yeah, is it on?
Yes.
Yeah, so when you do this, just, you have the board facing you with the connectors here for HDMI and power, and then you just simply pop it on like that. The next step is to secure the ice cooling tower to the Raspberry Pi 4, and you use the nuts supplied with the package to do that. All apart from the back left-hand corner here.
With the 2 next to it.
That's right. And because that's where we're going to be installing the real-time clock. If you don't have a real-time clock, you should install your nuts here so they're all fully secured. The trick to this is to simply place the nut on it gently like that and just slowly with 2 fingers begin to move it. And then once it's threaded in, you can just tighten it up like that. Yep. The next step is to connect up the power cables of the fan. The black wire is the ground, and in this video we'll be connecting the red wire to the 5-volt pin on the GPIO array. Now there are 2 options with this. You can either have it connected to the 5-volt pin or the 3-volt pin, the 3.3 volt pin. I have this connected to the 5-volt pin because then it gives maximum cooling. And for me, it's not intrusive, the sound. It's pretty quiet, actually. Ellie, if you take this red DuPont cable here and gently connect it onto the very end pin. Ellie, take that red cable and connect it to this pin here on the very end.
Yeah.
That's right. Just slide it on. Easy, yeah? It goes, that's it. It's easy. Okay, so that's the 5-volt power line there. And then we need to connect the ground cable as well. Okay, so Ellie, do you want to take the black cable and connect it to pin 39, which is the final pin there on the second row in? That's it. Perfect. That's done. The next step is to install the real-time clock. I've already installed the battery in mine, but if you haven't, you should install yours now. The next step is to wire it up. So the first thing to do, Ellie, is to take the male end, which is...
And use a red string.
And use the red cable, yeah. Because we're following my installation guide off the website there. So take the male end, which is the pin end, and put it into this one right here on the back left.
Why does it matter what colour it is? Aren't they all the same?
It only matters which colour they are when you're following a procedure or a standard. Inside, they're just copper wires, they're exactly the same. But having them colour coded allows us to know what we're connecting them to on the other end, because otherwise it won't work properly or it'll break things. So yes, but it's a good question. You can use any colours you like. These are just the colours that I happen to pick out of my big collection of DuPont cables. We're going to use the screw hole in the real-time clock for orientation. So you can see there where we've connected that one. So the next thing, Ellie, is to connect in the blue wire. So take the blue wire with the male end and position it next to the red cable on the right-hand side. Yep, that one. Okay, and then take the yellow cable and position it on the right-hand side of the blue one.
So we're just going to make a line?
Yeah, exactly.
Okay.
Finally, take the black one and insert that in front of the yellow one. Exactly. Okay, that's the RTC end done. Now that we've wired up the DuPont cables to the RTC, we need to connect them to the GPIO. We've just had a change in production crew here, so Sophia's going to be completing the assembly of the Raspberry Pi 4 before we move into the installer. The RTC is powered by the 3.3 volt pin on the GPIO array. So the first thing you need to do is take the red wire here and connect it to the last pin on the GPIO array.
Does this thing need to go in any certain direction?
No, it doesn't matter. That's right. Perfect. And yeah, exactly. And then next is the blue cable, and you position that on the pin on the left-hand side of the red one. Yep, that's right. And then the yellow pin, you position that on the left-hand side of the blue one. Again, all on the same line of GPIO pins. Again, all of this you can see is annotated on the installation guide on the Slackware documentation website.
And the black one?
Okay, so that's red, blue and yellow. That looks good to me. And then finally the black one, the ground, needs to go on pin 34, which is the 1, 2, 3. It's the fourth pin back. So it's 1, 2, 3. It's this one here.
This one?
Yep. That's correct, isn't it? 1, 2, 3. Yep, perfect. Now that we've wired up the RTC to the GPIO array, the next step is to secure it to the Raspberry Pi 4. My ice cooling tower came with an extra brass spacer here and an extra nut as well. I don't know if they all do, but mine certainly did, so I'm making use of it. And we're going to secure the RTC by doing that. So if you take that and screw it onto the top of that one, exactly. Okay, and then position the RTC on top of it.
Okay.
All right, and then we'll just put that on like that.
Like that?
Yeah, exactly. And then take the nut. Now that's a little bit fiddly, I must confess.
Okay.
There we go. Perfect. Okay, that is the Raspberry Pi 4 and the ice cooling tower with an RTC fully assembled. Okay, all we need to do now is connect the peripherals. So if you take the storage and connect that to the bottom USB port, the blue one there, because those are the USB 3 ports, which are the fast ones. You want your operating system storage to be on the fast USB ports there. Next, connect up the HDMI mini adapter to the first HDMI port on the left.
This one?
No, the other one at the top, that's right. Okay, perfect. And then connecting the power cable to the USB-C port on the end there, like that. We'll power it up later.
Is that in properly?
It is, yeah, you heard the click there. And that's pretty much it. We just need the keyboard, but we'll connect that up in a minute or two. Now that we've assembled the Raspberry Pi 4, the next step is to return to the installation guide and move down to the download section. We'll be following the installation guide here, and we'll be performing all of these steps on the Pinebook Pro. So the first thing we'll do is this small section here. CD returns us to the root of our home directory. Now we'll make a directory called Slackware and change into that directory. All right. Now, we're simply going to make a note of where our home directory is, because later on in this installation guide, we'll need that home directory when we use the root user to deploy the Slackware installer and the installation media onto the microSD card and the USB flash drive respectively. So we'll type in the command pwd, and in this case you'll see that it says /home/Moses//Slackware. Your home directory of course will be different, so make a note of what you have there. The next thing we need to do is to download and install the Slackware ARM GPG key so that we can verify the assets once we've downloaded them. To do this, select the line as shown from the installation guide and copy that into your clipboard and paste it into the shell like this, and then hit enter. As you can see, this is imported correctly. The next step is to specify which version of Slackware we'll be downloading. At the time of making this video, there is only Slackware Current, which is the development branch. So copy that line here into your clipboard and paste it into the shell and hit enter. Next, we need to specify the distribution server, which is the server where we'll download the assets from. I'll be using the distribution server that's in the documentation here, which is the master server for Slackware ARM. But if you have a favorite mirror that mirrors Slackware ARM, you can specify those details instead. Just note that the Slackware ARM on the right hand side of the colon is the name of the rsync module that's configured on the distribution server. So just make sure the details are correct when you go to download it if you pick a different mirror. Okay, so I'll copy that line, put it into my clipboard, paste it into the shell and hit enter. Now let's download the Slackware installer for the Raspberry Pi 4. As you'll see in the installation guide, we've still got a little bit more copying and pasting to do. You may prefer to copy this and paste it into a text file locally so that you can execute that. But I'll continue to move through this step by step by copying each line individually. The first thing to do is to download the Slackware installer for the Raspberry Pi 4. So copy the line there, including the final dot or period that you'll see at the end. Then copy that into our clipboard and paste it into the shell and hit enter. This installation image is a few hundred megs in size, so it may take a while for you to download that. Okay, that's done. Next, we'll download the signature file for the Slackware installer so that we can verify it. So again, copy that line here, including the final period or full stop, insert it into your clipboard, paste it into the shell and hit enter. This file is only a couple of bytes in size, so the rsync command will return almost instantaneously. Next, we'll download a tool that we'll use to verify all of these assets that we've downloaded. So copy that line here, including the full stop, and paste it into the shell and hit enter. This script is only a few bytes in size, so again the rsync command will complete almost instantaneously. Now we're going to download the Slackware tree. The Slackware distribution is approximately 4.5 gigabytes in size, so this could take quite some time to download. So this command consists of multiple lines. So simply copy all of the lines, 1, 2, 3, 4, again including the period or full stop on the end. Copy it into your clipboard and paste it into the shell and hit enter. And again, you'll need to wait a while for this to download. Okay, that's complete. Now it's time to verify the assets we've downloaded using the script that we downloaded. But before we do that, we're going to verify the integrity of the script itself. Copy this line here into your clipboard, paste it into the shell and hit enter. What you're looking for here is where it says good signature from Slackware ARM. If you find that the verification fails, the first port of call is to re-download the assets that are failing. If that doesn't resolve the problem, let us know on the forum and we can look into it. Okay, now that we've verified the integrity of the integrity checking script itself, we can now run that script to verify all of the other assets that we've downloaded. So the first thing we'll do is make the script executable. So copy the chmod 755 line into your clipboard, paste it into the shell and hit enter. Returning to the documentation, copy the line below it into your clipboard, paste it into the shell and hit enter. This script will now verify the bootware, the Slackware installer, and all of the Slackware installation media. This will take several minutes to complete. The verification has completed. What we're looking for here is 0 bad sigs. Again, if you find that there are any bad signatures, the first thing to do is to run rsync again to re-download that and rerun the tests. The next step is to write the Slackware assets to the micro SD card and USB stick or USB flash drive. The first thing that we need to do is to elevate our privileges to root, because we're going to be doing things that unprivileged users cannot do. For those of you who are familiar with other Linux distributions, you may be wondering why we're using su here rather than sudo for each command. Using su is the traditional Unix approach here. In fact, I'd never seen anybody using sudo the way it's used in Linux distributions until the mid-2000s. To me, as a Unix sysadmin, managing multi-user Unix systems, sudo was a tool that allowed you to give elevated privileges under particular contexts or for very particular tasks, where ordinarily a tool would be required to be run as root in order to function properly. But on some occasions, you'll find that tools that need to be run as root, some particular functionality that you could quite safely expose to users without having to make the full complement of the toolset available. For example, in one place I created a wrapper script for a tool that needed to run as root, and this tool managed an HPC cluster. Ordinarily, you wouldn't want to provide all of the users the access to that tool because they could wreak havoc on the entire HPC cluster management suite. However, it was a multi-purpose single tool, and the users would need to contact me to remove their own jobs from a queue. So I decided to make this wrapper script to make this self-serviceable. And the wrapper script was called via sudo, and all the wrapper script did was call the tool as root via sudo with a particular command line operator, with a particular job name. And so that enabled self-serviceability into this tool, still running as root, but the access of it was circumscribed via sudo and the wrapper. So that's to me what you use sudo for. But much of the documentation for other Linux distributions tends to use sudo for executing all commands that you run as root. However, I'm a traditional Unix user, and so to me it makes more sense if you open up a root shell, because you're going to be entering many commands as root here. So that's what we're going to be doing here. You might find in some Linux distributions that they actively block you from using su. So you may have to use sudo su. If you prefer to use sudo, or you need to use sudo, use sudo. But in Slackware, we can just type su and elevate ourselves to root. So let's do that now. So let's type su space followed by dash return. Enter your system's root password. Okay, so we now have a root shell. The first thing to do is to type ls blk-d, and this will list the block devices. As you can see, we have 3 here on the Pinebook Pro. We've got MTD block 0, MMC BLK1, and NVMe 0N1. Now, one of the things I want to point out as a significant caution here is that for most systems, you will find that you have /dev/SDA, or SDA as it would appear in the name column here. Whereas the Pinebook Pro has its operating system on NVMe storage, which does not present itself as SDA. I just want to caution you that when we insert the USB adapter with the SD card on it and the USB flash drive, it will appear in the Pinebook Pro as SDA. So we will be operating on that as SDA. But again, for most systems, it'll probably appear as SDB or SDC or even SDD, for example. So just be very careful here to check which the correct block device is for your system. And that's also why we're running LSBLK-D here, is to explore what we currently have on the system so that we can safely address the appropriate block storage device here. Okay, so with that said, let's insert the micro SD card into the USB adapter and then insert that into the Pinebook Pro. Now that the micro SD card and the adapter has been inserted into the USB port of the Pinebook Pro, let's run LSBLK-D again to see which block device it's been assigned. So you can see here that we've been assigned two to the USB adapter. We've been assigned SDA, which is the, as marketed, a 8GB SD card. But as we can see here, the capacity has been identified as 7.4 gigabytes. But SDA has been assigned to the micro SD card itself. And SDB has been assigned to the USB adapter itself. But this is not interesting to us. The easiest way to know that it's not useful to us in this instance is because it's 0 bytes. So we know that that's to do with just the USB adapter itself. Let's return to the documentation. We need to now write the Slackware installer to the micro SD card. So we need to CD to the directory into which we downloaded the Slackware assets. And then we need to unpack the Slackware installer and direct the output to the micro SD card, which in our case is not SDC, as you see in the instructions, but in our case on the Pinebook Pro, it is SDA. I just remind you again to double check all of these details to ensure that you're writing the data to the correct block device. Okay, so let's copy that line here, the XZCat line, because I'll remember the top one. So let's cd into /home/moses/slackware, because that's the directory into which we downloaded the assets that we made a note of before. Okay, and then we'll take that line and paste it in. Now, I'm going to be careful here, and I'm going to prepend the entry with a hash, which is a comment line. And that's just to be on the safe side. So there we go. So I've pasted that in. I'll type /dev/SDA, because that's the block storage device that's been assigned to my micro SD card here. Okay, I'll jump to the beginning of the line, delete that, and press enter. Now, these images are a few hundred megs in size, compressed, and they expand to a few gigabytes. So this may take several minutes to unpack here. The Slackware installer image has now been written to the micro SD card. So what we're going to do now is type sync and hit enter. That's SYNC. This command ensures that any data that's still buffered, awaiting to be physically written to the block storage, the micro SD card in this case, is written to the storage. This allows us to know that when we physically extract the storage from the machine, it should all be in good order. Okay, so now that that's completed, let's physically extract the USB adapter from the Pinebook Pro. Just to sanity test, we'll now run LSBLK-D again to make sure that the list of block devices matches what it did before we inserted the SD card into the Pinebook Pro. So let's type that in again. And as we can see, the list has reverted to how it was before. So there's no mention of SDA here. So now let's insert the USB flash drive or USB stick into the Pinebook Pro. And let's type LSBLK-D again. And as you can see, the USB flash drive is now presented as SDA. And it has a capacity of about 28 gigabytes. Okay, so now it's time to transfer the Slackware installation media onto the USB flash drive. So let's return to the documentation now. and scroll down to the section where it says write the Slackware installation media to the USB stick. And now let's create the ext4 file system on that USB flash drive. So let's take this command here, copy that into our clipboard. And note again that you need to be very careful here, because in the installation documentation it references /dev/sdb. On the Pinebook Pro there is no SDB, so this command simply would fail. But on your machine you may well have an SDB. So again, be very, very careful to ensure that you're specifying the correct block device when you do this. Otherwise you'll erase data on a different block device than you intended. So let's copy that command. And again, for safety, I'm going to prepend that line with a hash. And again, we're going to use /dev/sda because that's the block device that's been assigned to the SD card. Okay, so that looks good. So let's delete that there from the line and visually check it. Yeah, looks good to me. So we'll make the file system on that. That should take a moment or two. Okay, that's done. Okay, it's now time to mount the USB stick or USB flash drive. As you can see in the installation guide, we're using /dev/sdb. And we're going to mount it into the mount point /mnt/hd. Now this mount point exists by default in Slackware, and on my Pinebook Pro I do not have anything mounted at that mount point. If you're using Slackware and you do have something mounted at that mount point on your Linux host computer, you'll need to pick a different mount point. I don't know about other Linux distributions whether they have that mount point. My guess is probably not. So I'll leave it to you to figure out where to mount that on your Linux host computer. So what we're going to do now is we're going to mount that USB stick to our Linux host computer. Note that we didn't create any partitions on our USB stick, USB flash drive, because we don't really need to do that. And it's just more work for you to do. So we're just going to mount the bare storage device here, /dev/sda. Returning to the documentation, we now need to copy the Slackware tree into the mount point. Now we're just going to finally check to ensure that we're in the correct directory. As you can see on the screen, this particular shell has a prompt that exposes the working directory. So as you can see, it's /home/moses/slackware. Returning to the documentation now, copy the rsync line into your clipboard and paste it into the shell. Just remembering that if you need to use a different mount point, substitute /mnt/hd with that other mount point. Again, I'm going to prefix the rsync command with a hash for safety, then jump to the beginning of the line, delete the hash and execute rsync. Now, this Slackware distribution is about 4.5 gigabytes in size, so this will take several minutes to transfer all of this data onto the USB flash drive. The data transfer has completed, and now we need to unmount or U-mount the USB stick. So we're going to select that command there, and this time I'm just going to paste it straight in and press enter. Remember that if you have mounted the USB stick to a different mount point, you'll need to substitute /mnt/hd with that mount point. And as always, type sync to flush the data to the USB stick so that we can safely eject it. And we now no longer need the Linux host computer. We're finished with it completely for this installation of Slackware. So we can log out of our root shell. The simple shortcut here is just simply to press Ctrl and press D, and that will log you out. Or you can type exit or log out. Okay, that's done. Now let's finally remove the USB stick, USB flash drive from the Linux host computer. And now we're all done with a Linux host computer. Now let's insert the micro SD card that we copied the Slackware installer onto into the micro SD card socket on the Raspberry Pi 4. So just gently slide it in there. It doesn't make a clicking noise or anything, so just push it in until you can feel that it's home. Now we need to connect the USB peripherals. So connect the keyboard and mouse to the USB 2 port, which are the black ports. The blue coloured USB ports are USB 3, which have a higher data transfer rate than the USB 2. So you'll want to reserve the USB 3 ports for your storage devices. Okay, then what we're going to do is you need to connect the HDMI cable. Now we're going to use the TV here because we have an HDMI capable TV. So we're going to plug the HDMI cable from the TV into the HDMI port here on the adapter, like that. If it doesn't go in, don't force it because it's wrong. Okay, that's it. Yeah, that's good. I heard the click. Then connect the Raspberry Pi 4's power supply to the power cord with the inline power button on it, like this. And then plug the Raspberry Pi's PSU into the mains electricity. Okay.
Turn it on.
Yes, you can apply the power now. Now, as you can see, the Raspberry Pi 4 has not powered up, and that's because it's switched off with the inline power button. So if you just press the inline power button now, the Raspberry Pi has started to boot, and you can now see the output of the bootloader on the screen. The bootloader will now load the Slackware installer, the initRD, into RAM, then it will load the Linux kernel, and then it will load the flattened device tree, and it will boot the kernel. As you can see, the kernel is now booting. This will take about a minute or so, and then you'll be presented with this screen here. In this installation guide, we're going to be installing Slackware off the USB stick. So as you saw, this Raspberry Pi is not connected to any network. There's no wired connection here. The Slackware installer is not capable of using wireless networking, however, it is capable of using wired. So if you wanted to install over the network, you could connect an Ethernet cable at this point to have it pick up an IP off the network. But because we don't have a network connected here, we just need to wait until the DHCP client times out. At which point you'll be presented with this message on the screen informing you that the Slackware installer is ready and to press enter. So press enter now. We have a UK keyboard here, so we're going to press the number 1, press enter, then use the page up and page down and cursor keys to select the key map for our keyboard. Then press enter and press 1 again to confirm it. Next, return to the documentation and scroll down to the Setup Disk Partitions heading. We're going to follow the installation guide here, which creates a very simple partition table. So we're going to type in fdisk/dev/SDA. And then we're going to press P to print the partition table. There are no partitions on this NVMe storage, it's completely empty. But you can see it's the NVMe storage and it's about 500 gigs in size. Next, we're going to press N to create a new partition. We're going to take the default, which is P, so we'll press enter now. Again, we'll take the default of 1, so we create partition 1. And again, we'll take the default for the first sector, press enter. For the last sector, we're going to type in +4G, which creates a 4 GB partition. Press enter. Then we're going to change the type, so type T. Then type 82 for Linux swap. You can see it's been changed here. Next, type N, press enter. Again, we'll take the default for P for primary, press enter. Again, we'll take the default and create partition number 2. For the first sector, just press enter to accept the defaults. And now, for the last sector, press enter. And this will create a partition that fills all the available space on the block storage device. As you can see, partition 2 has been created and it is of size 460 gigs. Press P to print the partition table just to see how it looks. Okay, there's our 4 GB Linux swap. SDA1 and SDA2 is our 460 gigs partition, which we'll be using for the operating system and all of the user data. And now we're going to make partition 2 bootable. So type A and the default is good for us. It's number 2, partition 2. So press enter here to accept the default in this case. And again, press P, enter, to print that partition table. As you can see, there's an asterisk in the boot column to indicate that it's bootable. Finally, press W to write those changes to the disk. Now we need to load the Slackware setup menu, so type setup at the shell prompt and press enter. We've already selected our key map, so use the cursor keys to move down to the add swap item on the menu and hit enter. Just hit enter here. No, we don't need to check for bad blocks. Okay, hit enter again. And again we have a very simple setup, so just hit enter here. You do want to format it. You can pick any of the file system types here from the menu, but we will go with the default of ext4 or ext4. So hit enter. That will then take a moment or two to format. The next dialog is asking you to resize the partition on the SD card. For the sake of this simple installation guide, we want to say yes to this. However, if you want to use the SD card for something else, you might not want to do that. But again, we're going to keep it very simple and follow the installation guide. This will now resize the boot partition on here to the full extent of the block storage. And now it's going to change the bootloader configuration. And this is the information that's going to be entered into the operating system's file system tab. Hit enter. Okay, we're going to be installing from the Slackware USB stick that we created earlier. So move down to option 2 in the menu and hit the enter key. Now take the USB stick that we prepared earlier and insert it into the spare USB 3 port on the Raspberry Pi 4. Press enter at the dialog box. It will now search for the USB stick that we just inserted. There we go. The Slackware packages are grouped into what's called series. I'm going to install a full installation because that resolves any dependency issues between packages. Move around the menu with the cursor keys and use space to enable or disable the installation of a package series. So you may wish to enable or disable GNU Emacs or perhaps the kernel source. But again, we'll install everything here. Then press enter and press enter again to pick the terse installation option. The packages are now installing. Now, the installation of Slackware takes about 30 minutes. So what we can do while we wait, now I don't know if any of you remember the game Arkanoid or Breakout, as it was often called, but I've put a similar version inside the installer. So what we can do is open up another virtual console and launch this game called BrickTick. Now in Linux we have what's called virtual consoles, and we also have these in the installer. So the easiest way to do this, you can use the Alt key and the Alt and F1 for console 1, F2 for console 2, up to console 6. The way I use it is to use the Alt and the arrow keys, because then you can cycle through them all. So if you hold down Alt and press the right hand arrow key, and you'll see now that it asks you to activate the console. So press enter. Type BrickTick into the shell and press enter. The aim of the game is to clear all of the rows of bricks at the top of the screen. In doing so, little charms will drop down. And these charms are basically power-ups. And the idea is you have to bounce the ball off this bat and knock all the bricks out above. And the nuke charm is my favourite one. So press space to start the game. Then press L to launch the game. Use the left and right arrow keys to manoeuvre the bat around the screen and just bounce the ball off of the edges and try and catch those power-ups as well.
Oh, we have a similar new game, but it's like a very newer version.
Okay, it's game over now. I'm not going to say who won. Let's go back to the installer. What we need to do for that is simply press the Alt key and then press the left arrow key to go back. The Slackware installer is actually a very feature-rich environment. And it can be used for many different things, rescue environment. In fact, I used it to some degree to develop the AArch64 port because I needed something that was reasonably small that I could still work with. So it can be quite useful for a rescue environment as well. Okay, all of the Slackware packages have now been installed, and we're now in the post-installation configuration phase of the installer. The first question that you're presented is to do with configuring the console settings. This is all explained on screen, and I encourage you to read that through. But essentially, it boils down to this. If you plan on using a USB to serial adapter for the UART, so you can access the Raspberry Pi 4 over the serial console, then you want to go with the recommendation on screen, which is no. However, if you have no intention of connecting one of those adapters to the Raspberry Pi 4, you should say yes. All of the Slackware ARM build machines, however, always have this set to no, because I install them over the serial port. But for this Raspberry Pi 4, it's going to be a desktop machine. So again, I'm going to select yes here and go against what the recommendation is on the screen. The next dialog asks you about removing the Slackware installer from the SD card. This question is here because at certain points in the Slackware installer, you pass a point of no return. You can't return back to some previous configuration. It's already too late. So this option allows you to, if you get to that point and then realize that you need to go and reinstall from scratch, you would simply reboot, or in the case of the Raspberry Pi 4, you'd power cycle the machine and boot it again. And it would boot back into the Slackware installer. And that simply caters for that scenario. In this case, we will remove the Slackware installer image from the SD card. You may be tempted to keep it as a really good rescue environment. However, it contains Linux kernel modules for the running kernel, which after a while you would have upgraded the Slackware kernel and there would be a mismatch, so the installer would fail to boot. So it's not really worth keeping the Slackware installer around once the installation has been successfully completed. So again, we will say yes here to remove it. I'm going to go with the defaults for the mouse choice here. And yes, I want to load GPM because that provides mouse services within the Linux virtual consoles. So I will select yes. Yes, I want to configure the network. I'm going to call my hostname RPI and place it within the domain example.com. I'll say no to the question about VLANs. We don't need to do anything complicated here. I will also choose Network Manager. That's the easiest. Everything is good. Next, we confirm which services we'd like to start when the system boots. Typically, you'll be okay just accepting the defaults, but I always use NFS here. So I'm going to enable rc.rpc, which is the remote procedure calls client that you need to use NFS. And that's okay. So press enter here. To do this, you simply use the cursor keys and press space to enable and disable. That's how that works. So press OK. Yes, we want to choose some custom screen fonts. That's simply because the default font is way too small to read. So we'll select the font here. Press the T key, move down to the fonts that begin with T, then press page down a couple of times until you find TER732B and use the cursor keys there to select it and press enter. This font is the one that you are seeing right now within the installer. So that's why the font hasn't changed. If you select a different font, the screen will then render differently. I'm going to say no, the hardware clock is set to local time. That's what I always do. I'm going to press the letter E and then page down a few times until I find London. Press enter. I'm going to go with the defaults and I will select KDE here for the window manager. You can select whichever you like, but we're going to use KDE here. And we'll set a root password. Okay, press enter. Now press enter again. You'll be returned to the menu. Press the E key or use the cursor keys to page down. Press enter on the exit option. And now we can physically disconnect the Slackware installation media from the USB port. So let's do that now. Okay, so now press the enter key. Now at this point there are three options to complete the installation. You can either pick shell, and that will drop you into a shell prompt where you can access the installed operating system under the mount point /MNT. You may wish to do this if you want to change any kernel modules that are in your operating system initial RAM disk, and you can use the OS initRD manager tool to do this. There is a YouTube video available about how to use that tool, but we don't need to do anything for the Raspberry Pi 4. It's fully supported as it is. So press enter on the reboot option. The system is now rebooting, and as you'll see, the Raspberry Pi 4 is now booting again. So the bootloader is retrieving the operating system initial RAM disk, and now it's loading the kernel, it's booting the kernel. Okay, so the Slackware installation has complete and the operating system has been booted. So what we need to do now is log in and create ourselves a plebeian user.
Wait, why did we have the mouse?
Because we're going to use that in a minute. Actually, that's a really good question, because by default, Slackware boots into what's called run level 3, which is, as you see on the screen, it's text-based or console-based access to the operating system. If you want to, you can change Slackware so that it boots into run level 4, which gives you a graphical login manager. So something that you might see on Windows, for example, or other Linux distributions where you can log in with a GUI, basically. I personally don't really see the point of that. I've never done that with Slackware. I'm quite happy. In fact, I prefer access to the virtual console. So, for example, when I use my machines, I typically have a number of root sessions on these. I tend to use this myself, and I don't really care too much for GUIs at that point. If you want to change to a graphical login session, you can have a look in the installation guide that will show you how to do that. What we need to do first is to log in as root using the password that we set in the installer, and then we need to add ourselves a user. Would you like to add yourself a user?
No.
You want me to do it then?
Yeah.
Okay.
Wait. Do you mean are you doing the keyboard?
Yeah.
Oh, wait, yeah then.
Okay. First thing we need to do is to create ourselves what's called a plebeian user, which is an unprivileged user that you'll use to do all your work, your web browsing and everything else. The root user is only used to conduct system administration tasks. So let's create you a user. So type in add user, all one word in lowercase, space, your username. So you can use your username, either your name or, typically in Unix, you'll use a lowercase username. You don't have to, but it's generally a good idea. So just use a lowercase name there. You really going to call it Sophia Pig?
Yeah, pigs are the best animal in the world.
Unless you really know what you're doing, all you need to do here is just press enter for the default. So press enter again, press enter again, press enter again, enter, 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 enter. If you can type in your name if you want to, but I don't usually. We can just press enter. So press enter again, 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 again. Now type in a password.
I don't know whether it's typing or not.
When you type in a password, it's not echoed to screen, either directly, so that it's revealed, or obfuscated with an asterisk or something like that. So it's going to be blank. Okay, as you can see, it doesn't like your password. It's too similar to the username. So you're going to have to pick a more complicated one, I'm afraid. If you just press Control and D, and it will log you out. Okay, so now type in your username, press enter, and then followed by the password.
Wait, press enter?
Yeah. And then type in a password. Okay, now type in StartX, all one word in lowercase. Okay, so KDE has loaded. It's now time to start using the machine. Okay, so we're not using Ethernet for this installation at the moment. Fortunately, the Raspberry Pi 4 has Wi-Fi on board. So let's use that. Click on the Wi-Fi at the bottom there. Then type in a password, if you remember what it is.
I think so.
You need to make sure that the cursor is in the box though. Okay, press enter. For the sake of expediency in this video, I'm going to use the classic blowfish method. Type in a password, confirm it, then click OK. Okay, so we've connected to the wireless network here. So let's have a look at our YouTube channel. So As you know, I've got the Raspberry Pi 4 here connected to the TV using HDMI. And if it's actually turned on, which it is, we should also have sound coming out of the sound bar, which is connected into the HDMI TV. So let's go to arm.slackware.com and let's have a look. Here we go. Let's turn up the sound a little bit to make sure it works. And there we go. So as you can see, it's pretty straightforward to assemble a Raspberry Pi 4, download everything you need for Slackware and get it installed and get it working with wireless, internet and using a web browser. All pretty straightforward. The only final thing to say is look at the rest of the installation guide to see if there are any post-configuration activities or workarounds for bugs or anything like that that you might need to do. So with that, I'll leave you to it. Enjoy installing Slackware onto your Raspberry Pi 4. Take care. See you later.